This is the video for dividing monomials. On your formula chart, this is called the quotient of powers. So we talked about today that when you are dividing powers with the same base, you're actually going to subtract the exponents and keep the base. For example, if you look at the first example that I have here, number 2, we have k to the 8th divided by k cubed right here. So the first thing I'm going to do is write this out in expanded notation so that you can see why it works. So remember, k to the 8th power means 6, 7, 8. That you're multiplying k by itself 8 times. So that's what actually this numerator would look like if I wrote it in expanded notation. And then on the denominator, we have k times itself 3 times. Well, we know, according to our division property, that anything divided by itself is going to make 1. So k divided by k makes 1. It kind of cancels out. And then k divided by k will cancel out. And k divided by k will cancel out. And I notice that I'm still left with some k's in my numerator. I'm left with 1, 2, 3, 4, 5. And I know that I write that as k to the 5th power. Well, this is why it works, but the rule is that when you're dividing powers with the same base, notice these are both k's, I'm subtracting those exponents, and 8 minus 3 is 5, which is what the new exponent on k is once I simplify. Okay, so let's do another one and kind of apply that rule rather than writing it out in expanded notation. So when I look at number 4, I have two variables. I have a to the 6th, b to the 4th, and I have a squared, b to the 3rd in my denominator. So what I'm doing here is I'm dividing. So a to the 6th divided by a squared, that's dividing powers with like bases. So I keep the a and I subtract my exponents. 6 minus 2 is 4. Then I do the same thing with b. So if I have b to the 4th divided by b to the 3rd, those are the same base, so I keep the base, and I subtract my exponents. 4 minus 3 is 1. We don't write an exponent of 1, we just say a to the 4th, b. Now, earlier this week when we were working on our multiplying powers with like bases, which is our product of powers, and our raising a power to a power, people were getting confused about what operation we were doing. So when I'm subtracting my exponents, I'm still dividing. Remember, we're dividing out, and that's what's leaving us with a certain number of variables being multiplied together. So a to the 6th is like a times itself 6 times on top, and a squared is 2 a's on the bottom. So those cancel out. 2 of them go away, and I'm left with a times itself 4 times. And then the same thing with the b's. So this is the quotient of powers property if you look at your formula chart. On your formula chart, it is written as a to the m over a to the n equals a to the m minus n. So that's saying dividing powers with like bases, subtract your exponents, and keep that base. Okay, let's go ahead and move on and look at some more problems. So if you notice here, now we're starting to deal with some coefficients. So coefficients are just fractions, right? We have 4/8. So 4n to the 5th divided by 8n. If you cover up the n's and you just look at the fraction, 4/8 can be reduced to 1 over 2, okay? Then n to the 5th divided by n. So these are like bases, so I'm subtracting my exponents. So remember, when there's no exponent, it's like a little invisible 1. So n to the 5th divided by n would make n to the 4th. So you might see it written like that. You may see it written like this. Or you may see it written, why did I write a square? That should be to the 4th power. I don't know why I did that. That should be a 4. Or you might see n to the 4th over 2. All of those are equivalent. Usually I write it like this, but a lot of times you'll see it like that. Okay? All right, let's look at number 10. So here I have 36 over 54. So remember, if you're not great with simplifying fractions, you could always use your calculator. So if I do 36 divided by 54, it gives me 0.6666667. And to change that decimal back into a fraction, I hit math, enter, enter, and I find out that that is 2/3. Then I go ahead and I look at my x's. So I have x to the 9th divided by x to the 3rd. My quotient of powers property says that I keep the base and subtract the exponents. 9 minus 3 is 6. Then I move on to my y's. Y to the 5th divided by y squared. My quotient of powers property says I keep the base and I subtract my exponents. 5 minus 2 is 3. And this would be my simplified answer. Okay? If you feel more comfortable extending that bar all the way over, because those are on top, so to speak, then you may do that. Let's go ahead and look at another one. So now I'm starting to combine some of my rules together. I notice here that I'm raising a power to a power. I know that because I see these parentheses with a little exponent on the outside. So first I have to do my power of a power rule. Remember, when raising a power to a power, you are going to be giving that exponent to each piece of your monomial. So this square goes to the 5 and to the 3. So 3 squared is 9, and then x. Okay, so remember, when raising a power to a power, we multiply. So 5 times 2 is 10. So we have 9x to the 10th on top of 27x to the 3rd. Now I can use my quotient of powers property. So 9 over 27 reduces to 1/3. And then dividing powers with like bases, so quotient of a power, I keep the base and I subtract my exponents. So 1/3 x to the 7th would be my simplified answer. All right, why don't you go ahead and pause and see if you can do number 12, and then you can check your work with mine. So the first thing that I did here is I applied my power of a power rule. So this cube, or this exponent of 3, went to the b to the 4th, so I multiply there. 3 times 4 is 12, keep the base. This 3 goes to the a squared, so 3 times 2 was 6, keep the base. And then 2 to the 3rd power, that means 2 times 2 times 2 is 8. Then I just brought this denominator down. Now this time I actually get to just divide, because 8 divided by 4 is 2. So that's where this 2 came from. Dividing powers with like bases, so I kept the base and I subtracted. 6 minus 3 is 3. Dividing powers with like bases, kept the base and I subtracted. 12 minus 7 is 5. Okay, so here's another one, only this time, notice that the parentheses go around the numerator and the denominator. So I'm raising a power to a power, but I have to do it on the top and the bottom, okay? So this square is being applied to every piece on top and every piece on bottom. So I'm going to do this just like I have been. So my power of a power rule, I multiply my exponents whenever I'm doing this. So I have 4 right here, see? 4 squared. So 4 squared is 16. Then that 2 goes to a also. So I have an a squared. And then that 2 goes to b squared. So when I'm raising a power to a power, I multiply those exponents. So I get b to the 4th. Over, now I have to do the same thing on the bottom because these parentheses went all the way around it. So when I square 5, that's 25. Then it goes to the a, so a squared, and to the b squared. So I've done the power of a power rule. Now I need to see if I can divide. So you want to check and see, can 16 over 25 be reduced? Which it cannot, so it stays. So I still have 16 over 25. Then a squared divided by a squared, well, anything divided by itself is 1, so those cancel. and then b to the fourth divided by b squared. So dividing powers with the same base, keep the base and subtract your exponents. 4 minus 2 is 2. So 16 over 25 b squared is your finalized answer. All right, so on number 18, we're applying several rules. So the first thing I need to take care of is raising a power to a power. 10 squared is 100. A gets the squared, B gets the squared. Then I'm multiplying by 2a to the fourth, b to the third, and then at the end I have to do 4a to the fifth, b, that division right there. Okay, so I'm going to work across and then I'm going to do my division. So 100 times 2 is 200. Then I'm doing a squared times a to the fourth. So this is your product of powers rule. So with product of powers, you keep the base and add the exponents. So 4 plus 2 is 6. Then I do b squared times b to the third. Once again, that's your product of powers. So you keep the base and add your exponents. Now I still have this denominator I have to deal with, so I have a 4a, 5b, 4a to the fifth, b. So now I can divide. 200 divided by 4 is 50. A to the sixth divided by a to the fifth. So you keep your base, subtract your exponents. 6 minus 5 is 1. Then b to the fifth divided by b, keep the base, subtract your exponents. 5 minus 1 is 4. And this would be my simplified answer. So that had a lot of steps. So you need to make sure that you are keeping track of what you're doing and you're using your formula chart so that you know which rule you're looking at. This last problem is also going to review subtraction of polynomials or subtraction of a monomial. So the first thing that I'm going to do is I'm going to raise everything the power to a power rule. So I am going to give this square to everything in my numerator. So negative 6 times negative 6 is 36. X to the fourth raised to the second. So you keep your base and you multiply your exponents. So that's where I get x to the eighth. Then y to the sixth raised to the second gives me y to the 12th. So that is your power of a power rule. Okay, so please make sure that you're looking at your formula chart. When you have these parentheses, remember you're multiplying your exponents and keeping the base. Then I'm going to do the same thing in the denominator because notice it has a little square right there. So negative 3 squared is 9. X to the third raised to the second, that becomes a 6. Y to the fifth raised to the second, that becomes a 10. So same thing. I multiplied my exponents, kept my base. Now I still have to deal with this minus 7x squared y squared, but before I do, I need to divide here because that's what I do according to order of operations. So 36 divided by 9 is 4. X to the 8th divided by x to the 6th. So that's your quotient of powers. Keep the base, so I get x. 8 minus 6 is 2. Then I have y to the 12th power divided by y to the 10th power. I keep the base, subtract the exponents, and I get 2. So notice I now have like terms. Remember, like terms have the same variables with the same exponents. So if I have 4x squared y squareds minus 7x squared y squareds, I will be left with negative 3x squared y squareds. Remember that when you're combining like terms, or adding and subtracting monomials, the exponents don't change, only deal with those coefficients. Okay, this was a lot. We are going to spend a day of review putting it all together. I know it can be overwhelming, but use your formula chart and take your time and go step by step. That's my advice to you. If you're still struggling or you don't understand something and you want to come in for some extra practice, I have tutorials and I will see you in the morning. Have a great day.